Welcome to Copilot Podcasts. The device you're listening to this on right now has more computing power than all the computers that existed in 1970 combined. Yet the story of how we got here starts with something as simple as beads on rods from 3000 BC. Today, we're tracing the incredible journey of computing history, from the ancient abacus to artificial intelligence, revealing how human frustration with calculation errors sparked a technological revolution that transformed civilization. By the end of this episode, you'll understand the key breakthroughs that made modern computing possible and see how each innovation built on the last to create our digital world. Let me bring in someone who can help us navigate this fascinating timeline and uncover the surprising connections between ancient tools and modern technology.
You know what's wild? According to Live Science, if you were a merchant in the 1570s, your computer was literally a book. These Ready Reckoner books contained pre-calculated tables for things like compound interest, and they were incredibly popular for centuries.
Wait, books were computers?
Exactly. But here's the problem that would change everything. These books were full of mistakes, and that human error issue became a huge motivation for Charles Babbage to create his mechanical computing machines in the 1800s.
So the entire computer revolution started because people were frustrated with math errors?
In a way, yes. But let's back up even further. The abacus, which Britannica tells us dates back to at least 1100 BCE, was humanity's first real attempt at mechanical calculation. It's still used today, particularly in Asia.
That's incredible longevity for a technology. What made it so enduring?
It solved a fundamental problem. It assigned different weights to each rod, creating a positional system for numbers long before we had systematic notation for writing them down. But the real breakthrough came in 1617 with John Napier's bones.
Napier's bones? That sounds ominous.
Not as scary as it sounds. According to the research, Napier created pre-printed rods with embedded multiplication tables that could multiply and divide any two numbers. Live Science notes this was the first real threat to the abacus's dominance after 46 centuries.
46 centuries. So we're talking about one of the longest running technologies in human history finally getting some competition.
Right. And then in 1673, Gottfried Leibniz built what history tools calls a stepped reckoner, a mechanical calculator that could add, subtract, multiply, and divide. This was groundbreaking for its time.
But the real game changer was Charles Babbage, right? Tell me about his machines.
Babbage is fascinating because he's called the father of computers, but he never actually finished building his most important machine. In 1822, he started work on the difference engine to solve math problems and print results automatically.
Never finished? That must have been frustrating.
Incredibly frustrating. But then he designed something even more ambitious, the analytical engine. According to the sources, this machine had memory to store numbers, a mill to do calculations, punch cards for input, and could even print results.
Wait, punch cards? That sounds very modern.
That's the brilliant part. History Tools explains that Babbage borrowed the punch card idea from the Jacquard loom. Joseph Jacquard had invented a loom in the early 1800s that used punch cards to tell it which threads to use in what combinations and colors.
So textile manufacturing influenced computer programming? That's an unexpected connection.
Absolutely. And here's where it gets really interesting. The analytical engine was programmable, just like modern computers, but it was too complex to build with 1800s technology. Babbage's designs were literally a century ahead of their time.
That's both brilliant and tragic. But we can't talk about early computing without mentioning the women who contributed, right?
Exactly. Ada Lovelace is considered by many to be the first programmer. She worked with Babbage and understood the potential of his machines in ways that even he didn't fully grasp at the time.
And then there's Grace Hopper, who has one of my favorite stories in computing history.
Oh, the bug story. According to the Computer History Museum, in 1947, Grace Hopper found an actual moth stuck in the Harvard Mark II computer and taped it into the logbook with the note, "First actual case of bug being found."
So when we talk about computer bugs today, we're literally referencing a dead moth from 1947?
Well, sort of. The sources note that Thomas Edison was actually using the term bug to describe problems in inventions as early as 1876. But Hopper's moth definitely made the term famous in computing.
I love how these human moments become part of our technological language. But let's jump forward. When did we get to actual electronic computers?
The big shift happened during World War II. According to the research, electronic computers emerged in the 1940s, and this really sparked rapid technological progress. We're talking about the transition from mechanical to electronic systems.
What made electronic computers so revolutionary compared to the mechanical ones?
Speed and reliability. The sources mention that the transition from vacuum tubes to transistors revolutionized computing, making machines smaller, faster, and more reliable. This shift catalyzed the rise of personal computing.
And that brings us to a huge milestone, when computers stopped being room-sized monsters and became something individuals could actually own.
Right. According to encyclopedia.com, the personal computer was introduced in 1975. Before that, computers were very large and expensive, operated mainly by big companies. The microcomputer revolution of the 1970s changed everything.
1975, that's when computing became democratized?
Exactly. Wikipedia notes that after the development of the microprocessor, personal computers became low enough in cost to eventually become affordable consumer goods. Early ones were sold as electronic kits, mostly to hobbyists and technicians.
Electronic kits. So people were literally building their own computers at home?
Yes. And then we get to the garage legend, Apple. The Computer History Museum tells us that Steve Jobs and Steve Wozniak founded Apple in a garage in 1976, and it became one of the world's most valuable companies.
From garage to global empire. That really captures the speed of this transformation, doesn't it?
Absolutely. And here's what Bill Gates said about it. The sources quote him saying, "Personal computers became the most empowering tool we've ever created. They're tools of communication, they're tools of creativity, and they can be shaped by their user."
That quote really captures something important. Computers weren't just calculating machines anymore. They became creative tools.
Exactly. And then we get the internet revolution. According to the Computer History Museum, the first internet users were UCLA, Stanford Research Institute, UC Santa Barbara, and the University of Utah, connected on ARPANET in 1969.
4 universities started what would become the global internet. That's mind-blowing when you think about it.
And the pace of innovation just kept accelerating. The research shows that computers evolved from room-sized machines to pocket devices over 2 centuries, but most of that miniaturization happened in just the last few decades.
Speaking of miniaturization, I read something incredible about data storage density. Can you share that?
Oh, yes. The Computer History Museum notes that with today's magnetic storage techniques, more than 1 trillion bits of data can fit into an area the size of a postage stamp. From punched cards to that level of density, it's almost incomprehensible.
1 trillion bits in a postage stamp area. That puts the entire journey we've been discussing into perspective.
And we're not done yet. According to the American Journal of Artificial Intelligence and Computing, we're now seeing the emergence of AI and machine learning revolutionizing automation, data analysis, and decision-making processes.
So we've gone from merchants frustrated with calculation errors in books to machines that can learn and make decisions. That's quite a journey.
And the research indicates we're looking at emerging trends like quantum computing and edge computing. The evolution continues to accelerate.
What strikes me is how each breakthrough built on the previous ones. Punch cards from textile looms, electronic switches replacing mechanical gears, networks connecting individual machines.
That's the beautiful thing about this history. According to the research, computer science has become a dynamic, interdisciplinary field that continuously evolves to meet the needs and challenges of an increasingly digital world.
And the societal impact has been transformative. The sources mention that computers have reshaped communication, education, healthcare, and economies on a global scale.
Exactly. From their humble beginnings as calculating machines to the sophisticated interconnected systems of today, computers have transcended their initial roles to become indispensable tools driving innovation, efficiency, and progress.
So when you step back from all this, what we're really looking at is humanity's relentless quest to overcome our own limitations, starting with simple calculation errors and ending up with machines that can think.
That's beautifully put. And what's remarkable is that this journey from the abacus to AI represents one of the most transformative periods in human history, fundamentally altering how we live, work, and connect with one another.
The next time you get frustrated with a slow computer or a software bug, remember, you're experiencing the latest chapter in a story that began with merchants counting on beads and continues with machines that can process more information in a second than entire civilizations could handle in centuries.
And that story is far from over. With quantum computing and AI on the horizon, we're probably still in the early chapters of what computing will become.
From ancient abacus to artificial intelligence, that's the incredible journey we've traced today on Copilot Podcasts. Thanks for joining us on this whirlwind tour through computing history. The device in your pocket isn't just a phone, it's the culmination of thousands of years of human ingenuity, and the story is still being written.